to ST's private event at CES 2026. My name is Kirby Atwater, one of the product marketing engineers for MEMS and Sensors located in North America. Today we're going to be talking about a concussion assessment with the High-g IMU. So the LSM6 DSV family is our family of IMUs, and we have various different types for all different types of applications. Smartphones, wearables, smart tags, PCs, laptops, and gaming. Different variations of the G levels in these devices. They're all 4,000 degrees per second, but we have 16G, 32G, 80G, and we've just recently released the 320G accelerometer. So this is going to give some added capabilities for the sensor. We'd also like to point out that the DSV 320 did win the 2026 honoree for the CES Awards. So one of the differentiating features of the DSV 80 and the DSV 320 is the dual accelerometers. We now have a low-G 16G accelerometer and a high-G, either 80 or 320G accelerometer. So one of the differentiating features of the LSM6 DSV 80 and the 320 is the dual axis accelerometers. We now have a low-G 16G accelerometer and a high-G, either 80 or 320G accelerometer. This allows for both small signal differentiation and very high shock detection. What that allows for is different types of contacts for things that you couldn't sense with the 16G accelerometer. This is good for things like emergency calls, concussion monitoring, which we'll show today, intense movement tracking, fall drop detection, things like that. Inside all of our DSV family, we have the machine learning core, the finite state machine, adaptive self-configuration, and the sensor fusion low power. These are all features built into the sensors themselves. So this gives you a lot of different capabilities that we're going to show in the demo, but basically using the low G and the high G accelerometer to determine whether there was a possibility of a concussion. Okay, so for the demonstration, what we're going to do today is drop a wooden block on top of the helmet to give an idea of what the concussion capability would be or probability would be with somebody who didn't have a helmet on. So I'll drop it on the helmet. It takes about 10 seconds to do the calculations on the STM32 inside the sensor tile box, and we're going to get a head injury criterion and an abbreviated injury score. So what you can see here, this is showing the green waveform is the low G 16G accelerometer, and obviously the high G accelerometer is in purple. And what we can see here, based on this impact, was how very little information you were going to get from a 16G accelerometer. This really shows the best features of the DSV 320 by giving you a large dynamic range of shock detection with what you see. So in this case, we've calculated a head injury criterion score of 252.72, and this gives you the probabilities of an abbreviated injury score, possibly up to 0.68% of a severe injury. I want to thank you for your time and attention today, and I hope you found this interesting. For any further information, please go to st.com/MEMS. Thanks and have a good day.